Yeah, hello, welcome. So my name is Robert, I was introduced already. My company is basically similar to XTPL. We are doing 3D printers, so additive manufacturing systems, and high performance materials that come with them, as was emphasized, which is very important to have these materials available. And we come from background from Fraunhofer in Germany, ceramics research, so that's why ceramics is in the title too. And obviously they're good insulators. And I just press the button here, or where, this one. Okay, there it is. Thanks. And yeah, this is the content of my talk. So I will talk a bit about, so guide you through integration of electronic and mechanical functions here. So you don't only see electronics. Then we come to an explanation of how that process works. I provide a few more use cases and then give an outlook not only on additive but also on combination with subtractive method, and wrap the presentation up basically. And yeah, so I would like to introduce you, or like to invite you to follow me here, basically making a part at the beginning. So we have a task and specification here set out. We would like to manufacture a forming tool with integrated thermal control. So a forming tool is something that you want to shape, for example, blanks with, by, for example, mechanical force. But then additionally, we also have integrated thermal control there. So it means you also want to use heat as a means of shaping. Not only heating, but maybe also cooling, because it says thermal control. And here you see a geometry for such a tool. So it could be something like cylindrical. Then it has a patterned structured tip that should form that blank. And then there's something with a base or something where you can attach that, and maybe we need some interfaces for all these functions we want to put in. I was talking about mechanical shaping as well as thermal control, heating and cooling, so which may be electrical. And yeah, it should be made of a durable material, something that is hard, strong, wear resistant for a long service life. And in the best case, we have localized heating, so somewhere there at the tip where we actually want to form our blank. And for that, if we make this an electrical heater, then we have to have some interfaces for that too, to in the first place transfer power to the tool, and then through the tool to that internal heating source that we would like to have localized at the tip. And in the end, as I said, thermal control is not only heating up, but maybe also controlling how the heat goes down, for example, fast cycle times. In that process, in likely a high volume process, and you may also want to integrate cooling channels. So the last but not least, we have to mount that thing somewhere. So to some manipulator, could be a multi-axis system or something that is like a robot arm. And as you can see, the whole thing is basically an assembly. So it's a multi-material CAD design. And could this be done by multi-material 3D printing? Obviously, yes. So this is what my talk is about. Here you can see the 3D printed complex part. So looking a bit like what we just set out to do. This is, in this case, made specifically of a material that is also a cutting material, so you can cut cast iron with that. There's a heater integrated, as you can already see on the right, with these two different electrical resistances there marked on the very right, where we basically put in a coil at the top of the tip by lengthening the pathway, making it a coil, and also reducing the cross section, and therefore increasing the resistance of an integrated conductor in there. And then we run that conductor to the bottom and provide an interface there. In this case, I call this like a banana plug conductor because you can just plug this little banana plug in there. And in the center, you see the cooling channels running even up to the tip, so we can keep the shaft cool as well as can cool the tip deliberately. And at the bottom, there's an interface, a mechanical interface for mounting this at the tool base to, for example, a robot arm. And okay, that's pushed it a bit together, but as you can see, this is, in this case, it's fabricated in a single 3D printing build shop without assembly or joining. And here it is after debinding and sintering, so some kind of process is applied afterwards. The same question we just had at the end of the other talk. And here you can see it in heating operation. So here, this material combination can reach up to like 1400 degrees within less than 2 seconds with 48 volts. And it's a hard and wear resistant cutting material. And so this goes basically beyond, let's say, electrical electronic structures itself, not only resistors, conductors, and interfaces, but also